Number 1. The nucleus of one of the isotopes of uranium is represented by U-23892. The number of neutrons in the nucleus is, so here what we have is an atom of uranium which has a nuclear number of 238 and a proton number of 92. So we know that nuclear number equals to proton plus neutron. This is the nuclear number, this is the proton number. So 238 equals to 92 plus n. So n will be equals to 238 minus 92. So the value of n will be 146. So the answer is B. Number 2. The picture is of a child spinning top. The spinning top has a diameter 22 cm and spins at a rate of 6.5 revolutions per second. The speed of a point on the outer edge of the spinning top is. So here we have to calculate the velocity. We know the formula of velocity, which is v equals to omega r, right? So v equals to omega is 2 pi by t into r. So v will be 2 pi into, since here is 6.5 revolutions per second, we will have here 6.5 and 1 second as time and radius. This is the diameter of 22 centimeters, so the radius will be 11 centimeter, 10 to the power minus 2. So the velocity would be 4.5 meter per second. So the answer to this question is C. Number 3. The unit of magnetic flux density is the Tesla T. The unit T could also be written as, so here we have to use the formula for the force acting on a current carrying conductor, which is force equals to magnetic flux density into current into length of wire. So P will be equals to F by IL. Force is in newtons, so P equals to Newton by current is in ampere, length is in meter. So the answer is B. Number 4. In the particle accelerator called the LINAC, the particle gains kinetic energy because A magnetic field causes circular motion. No, this is not the answer because the LINAC does not cause a circular motion. Even if it did, it would not be the reason to increase the kinetic energy. Maybe if something stated that the radius of circular motion increased other than the scenario of LINAC, then this may have been the answer, that the gain in kinetic energy leads to the circular motion or increase in radius. B, mass is converted into energy due to E equals mc square, not B, since this equation is not related to the kinetic energy equation, which is half mv square. C, the tube increases in length. Yes, C is the correct information, but it is not responsible for the gain in kinetic energy. It is there to keep the alternating PD constant. So the answer will be D, since it is accelerated by the magnetic field, of course. 520 mu farad capacitor is charged so that the potential difference across it increases at a constant rate from 0 volt to 4.5 volts in 25 seconds. The current that is charging the capacitor is, so we have to calculate the current. We know the formula Q equals to CV, right? We don't have Q here, but we know the formula Q equals to IT, so we can put it here like this. IT equals to CV, I equals to CV by T, so C is 520 mu farad. Potential difference is 4.5, time is 25. So by calculator we will have 94 into 10 to the power minus 6 farad, which is 94 mu farad. So the answer is D. Mass m accelerates from rest through a potential difference v. The electron's final velocity will be. So the energy that are provided by the electric field are in electron volts eV. This is transferred to the kinetic energy of the electrons. So we have to equate these two. The energy provided by the electron volt equals to half mv square. So v square will be 2 eV by m. So v will be root over of 2 eV by m. So the answer is this, C. 7. Which of the following cannot be used as an electric field strength? So the mark scheme says the answer is D, but we have to prove that A, B and C is correct. So for number A, we have formula F equals to EQ. So E will be F by Q. And F by Q is Newton and charge is Coulomb. So this is B. We also know that if F equals to F by Q, Q is equals to IT. So this will be Newton by ampere second. This is the answer. For C, we have another formula which is EK equals to VQ, where EK is the electric potential per unit charge and this is in joules. And we have another formula which is E equals to V by D. So we'll have V equals to ED. So EK equals to V will be EDQ. So E will be EK by QD. So E will have joule, Q is charge, D is distance. So number C is also correct. So D will be the answer for question 7. Number 8. The graph shows how the flux linkage M5 through a coil varies with time. The EMF induced in a coil over the same time period. So we have EMF induced equals to N5 by T. So the EMF induced will be equals to N5 by T. We have the N5 here and T here. We also see that N5 by T is actually the gradient of this graph, and the gradient will be equal to this EMF. So here the graph is increasing at a constant rate, so the gradient is constant, and after that the gradient becomes 0. So initially the EMF will be constant and then it will become 0. So the answer is B. A model glider of mass 1.5 kg is launched using a large catapult. The glider starts from rest and the graph shows how the force on the glider varies with time. The velocity of the glider after 5 seconds is, so we have to find the velocity. We have the mass, we have time, we have velocity. So linking these formulas, we can have F equals to change in momentum by time. The change in momentum can be written as mv by time. So if force equals to mv by time, force into t actually becomes mv. So when we have force into time, force is this, time is this. So putting the values in the equation, 8 into 5 equals to mass. Mass is 1.5, 1.5 into v. So the velocity would be 8 into 5 divided by 1.5. From calculator, the answer is 13 meter per second. So the answer is B. Number 10. In particle physics, the mass of a particle is often given in giga electron volt per c square. If a particle has a mass m in kg, what is its mass in giga electron volt per c square? So its mass is in m kg. We need to have it in this form. So there is a wear on this. That is, we need to bring these units to m. So the rule is, to add a prefix, we divide. These are the prefixes. To remove a prefix, we multiply. So we have m. To add giga, we need to divide. So 10 to the power 9. To add electron volt, we also need to divide. To add c square, we need to divide, but this is given in giga electron volt per c square. So when we divide by c square, we actually have the c square at the top. So this is the answer, D.